Now I want us to look at two special types of graphs that we would use for bivariate numerical data: scatter plots and time series plots. As a reminder, a bivariate data set will have two observations, and we could label them X and Y. So you can think of these as having an ordered pair, so something like 14, 5.2 or 27.63, 18.9. These are two observations on the same individual. So one of the important graphs that we use for this bivariate data is the scatter plot. So scatter plots are going to have two numerical variables, and you're looking for a relationship. If you're hoping to see a relationship between two variables, you'll use a scatter plot. Now again, we'll almost always use StatCrunch for a scatter plot, but I'm going to quickly go through how you would do this by hand. You've probably done this before, but this example is looking at the price and the score of 29 different fitness trackers, looking at factors like the ease of use, the accuracy of counts. So for each fitness tracker, you have both the price and the overall score. Now sometimes it's important to consider which variable needs to be on the x-axis and which variable needs to be on the y-axis. You can make that decision by saying, which variable do I think is explaining the change in the other? So here, the price would explain the score, we would think. So we'll put the price on the x-axis and the score on the y-axis. So for each ordered pair, you would plot the point at the location that corresponds to the x value and the y value. So we see here 260 with a score of 87 is this dot on the right, and 150 for a price and a score of 83 is the second dot. And so you could go through your entire scatter plot, went too far. You can go through, draw the entire scatter plot with all of those points, or use technology. Don't do this by hand. And we see here that there does seem to be a little bit of a relationship between price and score. The more you pay, you tend to have higher scores. Now, this isn't an absolute strong relationship here. There is some variation, but we do see at least some relationship because we can see that it starts a little on the lower quadrant and then it ends up in that upper quadrant. But you have to be careful looking at things because not all high-priced fitness trackers were high overall scores. There were some scores that were not quite as expensive. Then we're also going to look at time series plots. Time series are going to be used when you have bivariate data, but one of the variables is looking at time, whether it's months, years, quarters, days, whatever. But you'll have these time series. Sometimes you see them as time plots, and it's just a collection of lines that's connecting the points while you're tracking them over time. So for example, so far in 2015, More Americans Exercising Frequently was an article based on a poll from Gallup looking at how often Americans were exercising. So we had data from the years 2008 to the year 2015 and the percentage of Americans exercising 30 minutes or more at least 3 days a week. So if we wanted to look at this over time, we would draw a time series plot. So you have the year on the x-axis and then the percentage on the y-axis. And you can see where it has increased and decreased very easily in a time series plot. So these are incredibly useful graphs when you're looking at how values have changed over time. Now, we notice here that there were 8 pairs and they're connected by these line segments. Those are helpful to help people see the trends that are happening from year to year. Now, sometimes you have data more frequently, so maybe you have monthly or quarterly. And so this is an example of what a time series plot would look like if you had monthly data. So you can see that it's changing a little bit from month to month. And you can think, what might be explaining some of these variations? And if you consider at the start of the year, it's January, and at the end of that year, it's December, you could think that perhaps in the summer Americans exercised more and in the winter they exercised less.